then let's start. So my name is Gábor Sörös. I'm a research scientist at Bell Labs, currently located in Budapest in Hungary. And I present today this open source WebXR client, which is a web app originally written by Michael Vogt, who was a member of OpenAI Cloud, but retired now. And I kind of took over the maintenance from him. It's a demo client, relatively simple, but it is good for creating quickly some demonstrations about developments in the platform. And Tamás Rigo is my colleague here, who is a very good engineer, and he completely rewrote the app from pure JavaScript to TypeScript in the past, let's say, 2 months. So there's a lot of work put in from him as well. So the first question, why WebXR when everybody is using Unity today? We also have a very basic Unity client, but the WebXR has a number of advantages. For example, you don't need to install an app. You don't need to install anything. It's relatively easy. You can just use your browser. In the future, it might be just running all the time in your glasses, and you can wander between experiences just by roaming in the building or on the street. You can always connect to newer things, and you can open stuff in your browser. So it's kind of universal. And ideally, it would be, of course, supported on a number of devices. In reality, this is today basically only Android Chrome. And the Edge has some partial functionality, but I tried, for example, spARcl is not running on Edge because we need access to the camera. I will talk about this on one slide later. And Edge is not allowing us that. And Safari as well is kind of closed at the moment. So that's the status. So if you want to use this, you need Android Chrome. We call it spARcl, Spatial AR Cloud Client, and it's available on this GitHub. I have a fork of it in the Nokia GitHub, and that's where I can contribute, and that is always pushed back to the main one. So just a quick recap how the OpenAI Cloud system worked. This was designed by James some years ago, and spARcl still has the same let's say workflow. So there is spARcl on this device, and there are some client libraries that connect first to some spatial service discovery, and here we retrieve a number of, based on course location, we retrieve a number of services, which can be localization services or can be some content discovery services and many other services. This is, of course, just one possibility of our implementations, and I really hope that in this work group we will come up with, of course, new extensions to this and new designs that are better in a number of ways. But spARcl is still following this workflow, and we implemented. This first version was created in 2021 for the ISMAR conference in Bari. This was a nice coincidence because our visual positioning partner, Augmented City, is a startup in Bari. So they actually had the full city mapped already for their own services. They provide touristic services. So participants could actually try all our demos in various parts of the city. Unfortunately, that conference took place during COVID, and only very few people could actually attend. But we were able to shoot some real footage in Bari. Here, an ISMAR logo is placed around a fountain. This is actually a playground of my kids with various random objects. This is my street. This was created by Michael Salazar, who is also a member of this group. And this is just an object in front of the office. And I will, in this talk, I will show you how all these are working and how you can actually set it up and extend it in ways that you want. Okay, so first thing is to go to this GitHub. You can clone it. It's super easy to start. You just say npm install. You change one line just to enable the HTTPS access on your local server. You add one line in the config file in a .env file. This is where spARcl will connect first for service discovery. And then you say npm run start basically on your server, and on your client, which is an Android phone, you need to go to the Chrome settings, and you need to explicitly enable WebXR because by default it is hidden, it is disabled. So you need to search for to Chrome flags and search for WebXR, and then just set this to enabled and restart Chrome. That's it. And then you just type in your IP address of your laptop, of your local server. Always use HTTPS, sure. It's important because we want to use camera and location access, so then it's required. And another handy feature is that if you use the USB cable to your phone, then on your desktop you can just say Chrome inspect devices. And it will, if you enable USB debugging, it will show you the debug page of the Android Chrome, and you can actually see all the logs and error messages on your desktop PC. I think this is super handy for development. The application is written in Svelte, which is like a JavaScript framework. I learned it just during this project. I'm not an expert in JavaScript at all, but yeah, it looks relatively easy. It consists of sorry, I'm pointing on the wrong screen. There is one application, and this application has various viewers, and these viewers have the main functionality. A viewer hides a wrapper over WebXR, a very simple WebGL engine. This is OGL. Yeah, you can look it up. This is a very minimalistic rendering engine. People experimented with, Mika, for example, experimented with putting 3JS here. In a very old version, we had Play Canvas here. So in theory, this rendering engine could be replaced. Right now, for my demos, OGL is sufficient. And we created some libraries that talk to the OSCP services for service discovery, content discovery, and localization. And then you can have various services that are needed to use this. So, for example, localization is for sure necessary. I will talk about augmented city, but here could be like Immersal or the one that we would like to build on top of HLock in this group. Let's see. And there can be a bunch of other services and content services. And I will show some examples that you can build many interesting things when you have multiple players. So I added some peer-to-peer communication with Peer.js and some streams with RabbitMQ. These are relatively new features. So I already talked about this. You go to, it's actually deployed. So the current version, the latest version, I deployed it yesterday at spARcl-orbit-lab.org. This is actually a server running at Rutgers University. And you can swipe through some intro and enable location, enable camera access, and then you will be presented this dashboard. This dashboard shows a number of things, whether location is allowed. It calculates your H3 index, and maybe James mentioned earlier that by design, the clients never share exact GPS locations with the services. They only use these H3 indices, which are relatively coarse. We do a lookup for the country, and you can pick OSCP test mode. There can be other development modes here. Here I am in front of our office, and there can be different services. It found now one content service and two content services and one localization service. If you don't have a localization service at home, VPS, then you can still use the sensor. So there is one debug setting here that that you can just use the internal sensors, and then you start the app, you localize yourself, and then you retrieve these contents. I have some test contents here floating in front of my office, but the idea is that it's relatively easy to extend this. So if you want to build your own demo, then you just need to inherit from one class and then rewrite a couple of methods, and then you have your own demo. Yeah, let's talk about the localization. So I mentioned Ominid City is a company in Bari, and they provide touristic services, navigation services for other companies as well. And they mapped the whole city of Bari. That's it's actually a pretty nice point cloud. And you can, they have their own API, but they also implemented the OpenAir Cloud, the geopose protocol, and I'm using them. So spARcl only understands the geopose protocol, so it expects to send in a specific format, and then it expects a geopose back. Here is an example point cloud of a small map, and when you send in a query image, it gets registered with this point cloud. And if the point cloud is registered with the world, you can calculate the global position and orientation of the camera. And then after that, you can retrieve contents and put them in your field of view. So if you want to use this, then what needs to be done is you need to use the Ominid City Scanner app, which is in beta mode, so you need to get an invitation for it. You take hundreds of pictures of your street. They get uploaded to their server, processed. You get some kind of point cloud, and Ominid City needs to be registered as a service in the service discovery database. It's anyone can do that because we have an instance running. I will talk about that later. Here is an example how their admin interface looks like. This is an OpenStreetMap of my office, and I took a bunch of pictures, and this is the point cloud that was created from them, and these are some example photos that I took. If you don't want to use this, you can still fall back to the sensor-based localization, so the GPS and the compass of the phone. There is I implemented this absolute orientation sensor, and the modern Android devices all have this. That means that it's already fusing all the available sensors to get the most accurate pose, and it's already like east-north up oriented. The problem is that it's quite inaccurate, especially if you're indoors. It can be totally off, but even outdoors, it can be like 10 meters off, and that means the AR objects will not show up at the exact same location as they should. But it's very good for testing quickly. Also, the coordinate system may not be consistent across all the devices. And something very annoying for me is that the coordinate axis somehow depend on the screen orientation, and I never had time to debug this properly. Right now, everything works only in landscape mode. So this is just a tip that if you want to use this, then use landscape mode, start the app in landscape mode. Otherwise, the coordinate axes are somehow mixed up. I mentioned that camera access is required because we want to send image queries. And this is not so easy. So you need this special flag, camera access, requested from the WebXR engine. And not all the devices, not all the browsers have this. And I wrote a kind of hacky method to actually capture the image from the GPU of the phone. And when that is extracted, I put it in an image, and then I can send it. But this is not an official way. And there's actually no guarantee that this will not break in the future. There had to be some updates already in the past 2 years. So this is a kind of risky feature. And I really hope that there are proposals to make this as an official feature. I'm afraid that this is still just getting delayed and delayed. we already talked about coordinate systems a lot. I just mentioned here that when you localize the self, then the AR session always has the origin where you started the application, and when you localize yourself, the geopose will be given in a local plane approximation with east, north, and up align. And what I do is I calculate the transform that brings your current local coordinate system to this east, north, up, and then I retrieve all the objects and place the objects with this transformation so that everything appears at the right place. If you reset and relocalize, then a new transform gets calculated, and that is applied to all the contents. Okay, and there needs to be some magic performed on, again, coordinate axis, because WebXR has this strange. Oh, sorry, I'm again pointing at the wrong screen. So Y up, and basically, if you look at the WebXR coordinate system and the east, north, up coordinate system, then this would be the east, this would be the north, and this would be the up. This is how I solved this problem. This was days or even weeks of debugging to get this right. Okay, so once you localize, you want to query your contents. Services we already queried before the localization, but we run again in this Orbit Lab org an SSD instance, so service discovery and the content discovery server. You can just go there, and there's an authentication window at the beginning, but it works with Google accounts. So you can just click on or log in with Gmail, and then you can enter. So there's nothing else required. The only reason why we did this is that if new contents are created, we would like to be able to associate them with somebody who created them. But everybody can read every content, and in theory, everybody can also delete and modify every content. You just wanted to have some kind of user ID. Important that the spARcl application is currently only for querying contents. It's not able to create contents, and the only reason is because it has no authentication feature. If somebody is willing to put authentication into spARcl, then we can also use the right APIs of the SCD. And there's also a very handy graphical user interface at this URL. So you can go in again, log in, and see in a graphical form where your contents are and what those contents are. It looks like this. This is actually brand new. I added this model viewer just 2 weeks ago. So this is a usual content record. There's some kind of ID, a type. It has some description, a geopose, and the geopose can be edited by like east, north, up Euler angles, and a URL to actual content. And then there is if you add here a model GLTF JSON, then it will create a small GLTF viewer window. If you add here an image or a text, then it will have an image viewer or a text viewer. Yeah. There is also a map view, so it's easier to pick a location if you go in this map view and just click on a map. Then this geopose gets populated here. Okay. Yeah, important that all the contents. Again, I'm sorry, I was pointing on the wrong screen. All the contents are public by default. What we create. Then spARcl can show some primitive content. So we can send around simple JSON descriptions that I want to have, let's say, a pink torus, or I want to have a purple sphere, and it is able to create these primitives that are anyway in the graphics engine. And here just some random objects were created by my kids. Based on these shared textual description. It can also have GLB models or GLTF models with texture. The texture is also a relatively new feature, but no complex shaders. So I have like one shader that handles everything. And Mika could talk about how he solved the complex 3GS content with an iframe actually overlaid on top of the spARcl app. Then also, this is brand new feature. This is going to be presented actually next week in the OGC point of interest contents. So I'm now looking around in front of the office. I pressed localize, so that an image was sent to Augmented City. I got back my geopose. Let me just show you here. This thing is actually the WebXR coordinate system aligned with east, north, and up. So this would be the east direction this way, and it's really that. And I query this kind of point of interest descriptions. I extract the name field and the geopose. And as you see, they really nicely show up. They even can have heights. So that's one of our nice meeting rooms up there. They nicely show up where they should. So this is a famous statue of a mathematical shape. And this is the office entrance and pad thai bar. As you see, it works quite well. I think there will be a reset here and a relocalize. I localize again. That's my local coordinate system over there. And you see things showed up. I localized in a different view and the things showed up at the same place. So it works, seems to work. Then I mentioned these primitive random objects. What is interesting in this demo is that the AR WebXR can already tell us a simple hit point with the ground. So it shoots a ray from the camera to the ground. It senses how far the ground is, and it can give us in WebXR coordinate system a hit point on the ground. So I can actually have a small cursor and select some things on the floor. So if we can calculate our geopose and transform our local coordinate system to geocoordinates, I can also do it backwards, where I can actually calculate the geopose of a hit point on the ground. So when the user clicks on the screen, I calculate the geopose of the hit point on the ground. I create a random object description and I share that with the other players. And then this is how I spawn all these objects. And this is an interesting feature because I can share an object with somebody else without having a common AR session like ARKit or ARCore has. There is no anchor here. Everything is just in the world coordinate system. And this is how it looks like. I recorded this video yesterday in the same room where I am right now, holding two phones in my hand. I'm looking around. I press the localize button on both phones at the same time. And as you see, okay, some objects, some virtual objects showed up in the room. We already know this small coordinate axis, and now you will see that I keep tapping on one of the screens. There's a small cursor here. Oh, sorry. And when I tap, an object is created. Now we should see the left one. So I will tap there. I will tap there, and an object is created. What is it? And to prove you that this is not this is really happening in geoposes, there is an OpenStreetMap view on the right side. This is actually when you open spARcl on the desktop app or on an iPhone. Then you end up at this OpenStreetMap view. As you see, this is the location of my office, and these are the objects that I just created. And also a new feature, I can also create backwards. So I can click on the map here, and then you see the objects start appearing in front of me. So you can actually live place content in front of somebody. Yeah, so this is a very new feature I'm really proud of. As you see, I mentioned extending spARcl is relatively easy. You only need to create 3 files, a new viewer svelte, just overwriting the base class, and the settings, which just has some extra fields that will show up in the dashboard where you can configure your particular demo, the user before starting. So there is somewhere in the docs there is a description how to do it step by step. And another feature that was added end of last year, and particularly interesting for this group, is the streams and the post streams of the cameras. sharing the basic objects was with this peer-to-peer PGS and auto-merge, because they can have some persistence. But what I'm going to talk about now is this RabbitMQ extension for it's a publish subscribe mechanism on some certain topics. You can listen to sensor values or camera geoposes or create robot waypoints. Here's a demo that I showed at AWE in end of last year. So here, this is the same room. In this room has robots and smartphones. Let me just stop it quickly. So this is the same room. This is my smartphone, the orange one, and this is a robot, and there should be another robot. No other robot. Okay, in this demo was only one robot. This phone is moving around. This is exactly the live capture of the screen of the phone, and this is again the OpenStreetMap view. So let's see what happens. The camera already localized, and the robot localized itself with its own camera in this small toy city. And I can give commands to the robot by clicking on this view. And the robot goes to this waypoint. This robot can navigate on its own. You just need to have a goal point for it. So now a goal was set here. And now comes the interesting thing, because I switch now to my mobile screen, and I tap on the mobile screen. Again, I calculate the intersection point with the ground. And from the intersection on the ground, I calculate the geopose, send it around in the network. The robot receives it, converts it back to its local coordinate system, and then goes there. And we can follow the whole thing happening here. Okay. Here things are still moving. So this is my phone. This is the waypoint. The green is the robot, and yellow would be the other robot, but it's not. So everything is happening in geopose streams. This is what I wanted to show you, because this is basically a prototype for the rendezvous use case that we would like to implement in this group. And yeah, this is something from Mikel. This is my last video. A very nice feature that if you click on the floor, it creates this signpost, and depending on where you are on the world, these things will always show on the right direction and tell you. You can even do the new sign that I want to see where is Bari, and that shows you depending on where you are actually in the world. He was in Norway when he shot this, so 2,000 kilometers is that's why it's marvelous so far. So that's all from my side. We can switch to a Q&A, and I'm happy to answer any of your questions. And you can take a look here. If you have an Android device, you can do a quick test already. Okay, so thank you. Should I stop sharing? I don't see the participant actually. Let me stop sharing.
I see some hands. Feel free to jump in with any questions.
Yes, please.
Yeah, okay, so this is Tracy. So hi, that was an amazing presentation. So I just in context, I'm actually an XR developer. So it was really good to see something related to augmented reality, because most of the stuff that I see is virtual reality and mixed reality, which is the kind of things that I do. I'm also a member of another working group within the Metaverse Standards Forum, which is the 3D web team. Okay, so they are particularly focused on WebXR, but I'm not seeing anything at the moment there with related to augmented reality, although I have created a use case for them, which is someone visiting a tourist town, then loading up their AR glasses or whatever they've got, browsing the web, getting an experience, and then actually having a tourist experience, which is going to be, you know, spatial anchors and maybe some tourist guide, some sort of you know, virtual tourist guide taking them around this. So I was thinking like geospatial kind of, to detect which town you're in and this kind of thing. So it was really interesting to see what you're doing and the different ways that you're doing stuff, because what you're doing, right, would work for that scenario.
It sounds like exactly what Augmented City is already providing as a product. And this is more like a toy and for research, but it could be built with it, yes.
Yeah. In terms of your presentation, are you going to provide a link to that so that we could use it for reference? I know we've got a link.
So
Yeah,
the whole thing is recorded. So you can always access this recording for sure. About the slides, yeah, probably I can put them on.
It's just because you've got links in the slides, that's all, which we
yes.
can't get obviously through. I know somebody provided the GitHub in the chat, so I've already accessed that. But it's just that, some of the stuff in your slides, you had like links and stuff, so that's why I'm asking.
Sure.
That's all.
Sure. Maybe I will export a PDF because the videos are like 500 megabytes, so I wouldn't put that online. But
it's just purely for reference, and if there's any, if there's any particular links in there that are important, just so we can access to them. That's all. Thank you.
Okay.
Thank you, Gábor. Just one thing, I have been looking at the SpARcl demo, and I will be happy to update it for the point of interest meeting, but I forgot where to make it happen. Should I just update the version that it is in this GitHub that you provided, GitHub repository, or
So it's in the OpenAI Cloud spARcl repo, and you could just fork that one and then create a merge request to that. I think that's the easiest way.
Yeah, because it is relatively easy to add a new thing, but I wanted to understand the 3D engine that you are using instead of forcing 3GS like we did
So
2 years
actually,
ago.
I would love to switch or have a branch with 3GS because it's just so much cooler. The OGL is really minimalistic. So basically, I showed everything that you can draw with OGL. And it would be nice to have a version with the 3GS properly integrated, because there you can have some physics and interaction and so on. And it's not possible with OGL.
Okay, I will be working on my own fork this weekend and talk with you later. Thank you very much.
Any other questions?
That was fantastic, Gábor. As always, it's really great to actually see these real-world use cases coming to life. I think it makes the technology that much more relatable. And just to add on the AR side, as Tracy mentioned, this actually came up in the South by Southwest discussions the other day. But there's often this perception that metaverse, implies VR. And of course, our working group, Real Virtual World Integration, we believe that the real world interaction and AR experiences are super important. It brings so many other dimensions in. It brings in the IoT aspect, right? Your real world digital twins, smart city. And ultimately, it's more of a natural experience, I would say, for humans. So.
I had a quick question regarding the SCD, or your spatial content discovery server. Is that expected? I mean, would it be possible to run a local instance of that? Say you want to run like out in the desert somewhere or something like that, you don't have like an internet connection. Could you run something like that right at the edge to enable these kind of experiences?
So I could even pass this question on to James because he designed that thing.
Sure.
So I think yes.
Yeah. So Rob, this is the content discovery that we've shown before.
Right.
All the information's there in the GitHub repo. It is really exposing a REST API, and I think at this point, what's most important is that content record. From an implementation perspective, what we initially did was using some decentralized technology to allow synchronization across providers. That will likely change, right? We're not too attached to the specific implementation, but you can absolutely take the code directly from the repo and pretty much run it anywhere.
Okay. I just think more about how you would enable more of an intelligent infrastructure that is can handle like environments where you might have challenging reception and that sort of thing, but still enable the experiences, autonomous systems, the AR, XR experience, even though you don't necessarily have connectivity. And I often like to say, well, will this work out on a cruise ship? That may not have that kind of connectivity, and you don't necessarily need to have geopose. You could do everything locally, or in orbit or something like that. So I like to do that sort of thought experiment to see how we could do the tiling or mosaicing of the content and run it in geopose if necessary.
And for that, I recommend to read up. There's some documentation on it written by Michael on how this peer-to-peer sharing is solved between the clients, because they use this auto merge, which is a super cool thing. It's like a Google Doc editing. So when you create one of these random objects, it's actually shared with the others, but it's also written in an auto merge document, and those can persist. And they can be synchronized when they are online, but when they're offline, they are actually edited locally and then merged later. So that could actually totally work for the idea that you just presented. So we can have multiple contents there. When you're offline, you just populate the document, and then whenever you get online, you actually sync with all the others.
I think Miko had his hand up.
Yeah, just one recommendation. I see that you included the geopose, the quaternion, and the Euler angles, but since back then we included the geopitch roll kind of orientation, and that solves the issue of what you call Y and what you call Z, the vertical vector and everything. So maybe you want to include it into the user interface so that it is easier for people to understand that first you rotate things with the yaw angle, pitch and roll, and that is like much more intuitive for the end users, I believe.
So I always use the quaternions everywhere, and this the Euler angles are here only used to rotate basically when you already place the object and you want to, let's say, turn the duck towards east, to look towards east, so to look at particular directions, because for me that's impossible to do with the quaternion. But yeah, we can add more fields there, sure. Maybe one thing I already started but never had time to finish is searching, because now the discovery is done with these H3 indices, and if you are starting in a particular H3 index, you are kind of bound to it. So the discovery is not happening continuously, and it's not happening correctly probably at the boundaries of these H3 indices. So if you happen to be at the edge of an H3 index, you only get the ones that are closer to you and not the other ones. I think this is wrong. And this should be done a bit differently. So this is a work item that somebody should volunteer for to make this really usable. When you actually walk down the street, you pass multiple of these cells, and you want to have the contents continuously queried.
Yeah, we should probably open an issue on the GitHub repo if we don't have one already. I see there's a question in the chat about Apple support for WebXR, and
I have no idea about that. I don't know.
Yeah, well, so
it doesn't work on iPhone. I tried.
I was curious. We've been wrestling with some of these gaps in WebXR, as well as, of course, lack of support from certain devices for a number of years. I wonder if there's some way we could maybe revisit that, enumerate the issues, and perhaps use the weight of the MSF to help push some of this stuff forward.
Yeah, thank you very much for the presentation, Gábor. It was really interesting. Yeah, I think the problem with WebXR on Apple's devices, yeah, this is a big problem, to be honest. In the end, whatever we develop, if such a big company is blocking the whole work, then yeah, you have like over 50% of the users who can't use the open web, right? So then, yeah, I don't know why are we doing this hard work when it's going to be blocked. In the end, we have to download apps again and use the apps. And yeah, I'm just a bit disappointed. Yeah, but
I've
this is
seen in
how
the
it
news
is,
that
right?
the glasses, the new Vision Pro glasses, they will support WebXR, but I
Yeah,
don't
but
have
they're
those.
not glasses, right? You're not going to walk around your local town with a bloody
Oh,
Vision Pro on your head, right? You're gonna
Yeah, I
you're
mean,
gonna want
for the next version, yeah.
it's
Yeah,
even
yeah,
worse.
I know that's the direction they're going in, right? But it's not supported on the phone, and it's not supported in if they're ever, well, maybe you're right. If they do provide actual glasses that you can wear walking around a town, maybe they will. But at the moment, for any AR devices, they're not doing it right. So
On the glasses, the WebXR VR is working actually, but the AR is blocked. So you are
yeah,
not.
and by glasses, let's just be clear. The Vision Pro are not glasses. This is a headset, right? This is not
Yeah, it's
glasses.
VR. Yeah, the marketing is working.
This is not glasses. You're wearing this at home, right? You're not walking around the streets with this huge monstrosity on your face. So anyway.
But yeah, it's more about, it's not technical. It's just they just block it for the money, right? So they want to force the
Yeah,
people
yeah. It's the App
to that.
Store, right? They want the revenue from the App
Uh,
Store, for sure.
their biggest revenue is from the App Store. So why should they block this part? So it's clear. I know they also did the same with Flash. It wasn't just because of the security, blah blah, but it was because of the free, accessible, interactive stuff on the web with Flash. They blocked it, so people have to download the apps from the App Store. So it's the same happening again. So.
Yeah, it's a pity. But is it possible to use some of these Web 2 app solutions to create a version without having to re-implement the entire thing in Unity?
Sure, it's possible, but not.
Cordoba, I think it was called, but that was the solution that was deprecated. There are others that are trying to take the web APIs and implement them into their app systems. I know it's not a perfect solution, but at least we don't have to spend too much time rewriting the entire thing.
As long as your solution is web-based, it won't work since Apple, the iOS devices don't allow to have other web renderers than their Safari kit. So it's not possible. So
I believe that was the point that they were making like their own web engines so that you could use web APIs, but go through the middleware and generate an app. But I will have to check up to make sure. Just mention that that might be a possibility that we should explore.
I believe a new EU policy is requiring Apple to open up the App Store to support other web browser render engines. So
true, at least in EU, that's true. But let's see. Yes.
Yeah, so EU regulations may sort some of this out. On the mediation platforms, I'm not sure if they were actually supporting WebXR.
No, it's a very small niche. They didn't really focus on WebXR, but
right.
they forced them, for example, for the PWA apps, the PVA, the web apps,
Yeah,
progressive web apps,
yeah.
and also the USB-C and also the alternative app stores. but WebXR wasn't written anywhere, so maybe the mainstream doesn't know anything about it, so they just can still block it, right?
Yeah, yeah. And I think on Apple, it's the case that even when you have other browsers available, they're still using WebKit under the covers of something like this.
Yes, it's still Safari. Yes, yes.
Right. Anything else?
So thank you very much. I am preparing now PDF version of the slide that I can send it to James and he can upload it.
Excellent. Thank you so much, Gábor. This was fantastic.
Sure.
And I'll definitely broadcast the recording out to the entire distribution.